everyone, I am Binila and I am excited to guide you through the journey of Web3 technologies. So, today we are going to dive into one of the most important topic, that is smart contracts. Smart contracts. So, in this video, we will cover about what is smart contracts, its advantages, disadvantages, then use cases, then its an example code. So, what is smart contract? So, imagine a traditional contract instead of being written on a paper and enforced by legal contracts. It's a self-executing code stored on a blockchain technology. So, these smart contracts are powered by blockchain technology and have the incredible ability to execute and enforce agreements without the need for intermediaries.
If suppose two parties have to get to a contract, they will utilize the services of a third party whom they have to trust and get the contract executed. Now, with the introduction of smart contracts and the technology which is evolving, it removes the dependency on such third parties and automates the execution of such smart contracts. Each computer on the network or node stores a copy of all existing smart contracts and their current state alongside the blockchain and transaction data. When a smart contract receives funds from a user, its code is executed by all nodes in the network in order to reach a consensus about the outcome and resulting flow of value. This is what allows smart contracts to securely run without any central authority, even when users are making complex financial transactions with unknown entities. To execute a smart contract on the Ethereum network, you will generally have to pay a fee called gas, SHU, named because these fees keep the blockchain running. Once deployed onto a blockchain, smart contracts generally can't be altered, even by their creator. There are exceptions to this rule. This helps ensure that they can't be censored or shut down. Here, how it works. When two parties agree on a contract, they write the terms of the agreement into the smart contract. The contract is then uploaded on the blockchain, where it is verified and stored. Imagine a smart lock that automatically unlocks your door when you enter the correct code. Similarly, smart contracts act as digital locks that automatically execute transactions when certain conditions are met, providing secure and transparent interactions on the blockchain. Let's go through the advantages of smart contracts. Trustless transactions. These self-executing contracts operate on blockchain networks, automating transactions based on predefined conditions. Transparency. Every transaction and action performed by a smart contract is recorded on the blockchain for all to see and eliminates the possibility of disputes or discrepancies. Security. Smart contracts are secured by cryptographic techniques and deployed on decentralized blockchain networks resistant to tampering, fraud, and unauthorized access. Efficiency. Say goodbye to lengthy paperwork and manual processes. Smart contracts automate transaction execution, streamlining processes and reducing the need for intermediaries. Cost savings. By cutting out intermediaries and automating processes, smart contracts significantly reduce transaction costs, making them attractive options to optimize their operations. Programmability. Smart contracts are programmable, allowing developers to create complex and customized agreements with a wide range of functionalities. They can incorporate conditional logic and loops to automate various business processes and transactions. Global accessibility. Smart contracts enable borderless transactions and interactions, allowing participants from different geographic locations to engage in agreements and transactions seamlessly. Now let's talk about disadvantages. Immutability. Once deployed, smart contracts cannot be modified, which can be problematic if there are errors or bugs in the code. This lack of flexibility can lead to significant consequences if issues arise after deploying. Complexity. Writing secure and reliable smart contracts requires a deep understanding of blockchain technology and programming, making it challenging for developers who are not familiar with these concepts. This complexity increases the risk of coding errors and vulnerabilities that could be exploited by attackers. Security vulnerabilities. Smart contracts are susceptible to various security risks, including coding errors, vulnerabilities in the underlying blockchain protocol, and attacks on the network. Security vulnerabilities can result in the loss or theft of funds and compromise sensitive data. Human error. While smart contracts automate the execution of agreements, they still rely on humans to write the code and deploy the contracts. Human error in coding, testing, or deploying smart contracts can lead to unintended consequences, including loss of funds or security breaches. Let's dive into that exciting world of smart contracts and explore how they have impact in various industries. Finance. In the world of finance, smart contracts power decentralized finance, DeFi. Applications like lending platforms and decentralized exchanges. They enable peer transactions without relying on traditional banks or intermediaries, offering greater accessibility and lower fees. Supply chain management. Smart contracts streamline supply chain processes by automating tasks like tracking shipments and verifying product authenticity. This ensures transparency and reduces the risk of fraud or errors along the supply chain. Insurance. Smart contracts automate insurance processes from policy issuance to claims processing. For example, insurance payouts can be triggered automatically based on predefined conditions, such as flight delays or adverse weather conditions, reducing processing times and improving efficiency. Smart contracts are written using programming language in Solidity. We'll create a simple contract that stores a single integer value and allows users to get and set this value. Here's the code. Let me break it down for you. This is simple token contract called mistoken. We start by declaring a mapping called balances, which keeps track of the token balance for each address. Next, in the constructor function, we assign an initial balance of 1,000 tokens to the contract deployer. Then, we have a transfer function that allows users to transfer tokens to each other. It checks if the sender has enough tokens before transferring. Lastly, we have a balance of function that lets users check their token balance. And there you have it. With this smart contract, users can transfer tokens securely and transparently on the blockchain.
In conclusion, smart contracts are transforming the way we conduct transactions in Web3, therefore providing unparalleled efficiency, security, and transparency. So, thank you for joining us on the exploration of smart contracts in Web3. So, don't forget to share, like, and subscribe. Thank you.